Welcome to the next lesson in our unit on nonlinear functions. This next learning target 2, is going to cover polynomial division. How do you divide polynomials and find other factors? Do you remember long division? It's a skill we don't use as often anymore since we get very used to using a calculator in Algebra 2. But let's just remind ourselves of what it means to divide a denominator into a numerator. 12 goes into 27 2 times. 12 times 2 is 24. I subtract these, I get a 3. Bring down the 7. 12 goes into 37 3 times. That's 36, leaving me with 1. And I bring down the 1. 12 does not go into 11 evenly. It is smaller, so this is what we call our remainder, and we write it as 11 over 12. So the answer is 23 and 11/12. And the other coefficients are -4, 3, and 2. So let's list these across the top of this synthetic division setup. Out here on the side of it, what I'm going to do is write down what the root of this is. And remember, the root of this would be x equals -2. And this is how synthetic division works. We are going to bring down the 1. 2 gets multiplied by the 1, which gives us a -2. I then add these two to get my next number down below the division lines. -2 and -4 make -6. Again, I take -2 and I times it by -6 and I get 12. Again, I add down and I end up with a 15. -2 times 15 gives me -30. And again, I add down and I end up with -28. So the numbers that we end up with are coefficients, just like the numbers I began with are also coefficients. So the last number is actually your remainder. The second number is what we call our constant. And then as we increase in that, we have the coefficient for x and also the coefficient for x squared. If there are more numbers that came before this one, as we did our division, there would probably be an x cubed, an x fourth, and so on. So now it's time to write out our answer. So our answer would be a 1x squared minus a 6x plus a 15, and then we have a remainder. Remember, remainders are actually fractions, just like we had in our long division. So what were we dividing by? We were dividing by x plus 2. So it's 28 over x plus 2. So this is the result of dividing the polynomial x cubed minus 4x squared plus 3x plus 2 divided by x plus 2. It doesn't look any simpler or smaller, but if you consider the degree of our answer, which is a 2, and we started with a degree of 3, this answer actually is much smaller. Let's take a look at something interesting. I want to just show you guys a little experiment. I want to take this -2 and I want to plug it into here since it is an x. And let's just see what we get. -2 to the third power minus 4 times -2 to the second power plus 3 times -2 plus 2. If I evaluate this, I end up with -8. -2 squared is 4. 4 times 4 is 16. 3 times -2 is -6 plus 2. I end up with -28. So this is interesting to realize, is that if you plug in the root of the factor into the polynomial itself, you actually end up with the remainder. So this leads us into what's called remainder theorem. If a polynomial is divided by x minus c, and c is a number, then remainder r equals f of c. In other words, if you want to find the remainder and not actually do the division, all you have to do is plug in c and you get r. So let's do that for this problem right here. X cubed plus 3x squared minus 45x plus 21 divided by x minus 5. In this problem, our c is a positive 5. So let's plug that into the polynomial and figure out what the remainder could be. We have 5 cubed plus 3 times 5 squared minus 45 times 5 plus 21. So let's start to simplify this. 5 cubed is 125 plus 5 squared is 25, and 25 times 3 is 75, minus 45 times 5 is 225, and then we're going to add 21 to this. So 125 plus 75 minus 225 plus 21, this equals negative 4. So the remainder is negative 4. So our R is negative 4. We can even use this if we know what the remainder is and we know what we're dividing by to help us figure out missing pieces of a polynomial. In this polynomial, we want to figure out A. A is missing. We're going to try to figure out which number is the coefficient that should be in this A position. So to do this, we need to know what C is. So right here, we realize C is 2, and our remainder is 0. So if I plug in 2, it should come out to 0. So let's do that. Let's plug 2 into the polynomial. 2 to the third power plus A times 2 to the second power minus 2 times 2 minus 24. And this better equal 0, because it has to equal the remainder. When I plug in 2, it has to equal 0. I'm plugging in 2, so there it is equaling 0. Let's start to simplify this. 8 plus 4a minus 4 minus 24 equals 0. So I end up with 4a and 8 minus 4 is 4, and 4 minus 24 is negative 20. Let's add 20 to both sides and divide by 4. So the a should be a 5. That'd be the correct a to go in here, so that when you divide by x minus 2, there is no remainder at all. Let's try doing another synthetic division. We're going to divide m cubed minus 4m squared minus m plus 12 by an m minus 3. We need to figure out what our c is, and the c in this problem is a 3. Remember, because it would be m minus c. So let's set up a synthetic division with our coefficients. The coefficients in this problem are 1, negative 4, negative 1, and positive 12. And now we're going to write our c number right here, a positive 3, not a negative 3. Let's bring down the negative 1, 1. Then let's multiply 3 times. Now let's multiply 3 times 1, which gives me 3. That goes in the next spot. Remember always to add down. Negative 4 plus 3 is negative 1. And now 3 times negative 1 is negative 3. Don't forget to add down. Negative 1 plus negative 3 is negative 4. 3 times negative 4 is negative 12. And we add down, and we end up with a remainder 0. So my answer here, since there is no remainders, see, there is no remainders, there's no remainders. The negative 4 is the constant. Okay, the negative 1 is the x, and the 1 is the x squared coefficient. So I end up, actually, instead of calling this a c, I could see how that could be confusing with this c. Why don't we call this spot right here the number, okay? The number at the end with no variables next to it. So now let's write out our answer. We have a 1x squared minus x minus 4, and that 1 in front is really optional. And so I end up with nothing after here because there is no remainder. So do know that when there is no remainder, it means that what you were dividing by from the very beginning, m minus 3, is a factor. So not only is the answer from division x squared minus x minus 4, but we also now know that m minus 3 is a factor because it divides evenly into the polynomial. In the same way that if you divide 12 by 3, you get a 4. You get no remainders, and that is why 3 is a factor of 12. We can use this fact of getting a 0 remainder to continue and find all factors of a polynomial after we do division. So in this problem, let's figure out the c. Okay, x minus 5, that means it's positive 5. And let's start to set up our synthetic division. The c number goes here on the outside, and we list our coefficients, which are 1, negative 9, 8, and positive 60. Let's start our synthetic division. Bring the 1 down. 5 times 1 is 5. Then we're going to multiply. That's the multiplying. Next we add down, and we get negative 9 plus 5 is negative 4. 5 times negative 4 is negative 20. We're going to add down. 8 minus 8 plus a negative 20 is a negative 12. And 5 times negative 12 is negative 60. So when we add those together, we do end up with no remainder, as we expected, because the problem did tell us that x minus 5 is a factor. So since it says x minus 5 is a factor, you better get no remainder. Okay, let's write down what we have. We have ended up with no remainder at all. Negative 12 is just a number. Negative 4 goes in front of the x, and 1 is in front of the x squared. X squared minus 4x minus 12. Now, I am going to put this in parentheses, and I'm going to put it here in the following parentheses the factor that I know for certain, which is an x minus 5, the thing that I use to divide by. I'm taking a close look at x squared minus 4x minus 12, and I am realizing that that is factorable more. I could factor that down into a 6 and a 2. 2 times 6 is 12, and 6 minus 2 is 4. So let's put negative here, positive here, x here, and repeat the x minus 5. This is my answer. These are all the factors. So again, just to recap, we use synthetic division to divide. We're using the 5. We make sure we end up with a 0 remainder because it said that this is a factor. Using those leftover pieces, I write down my answer with the original factor, x minus 5, and then I look at this trinomial and realize that I can factor that quadratic down a little bit more into an x minus 6 and x plus 2. Okay, if you have any questions, make sure you get those down to the left column so that we can answer them in class. If you have any immediate questions, you can shoot me a text using our texting service, Remind. And the last thing that I want you to remember before you come into class is sometimes you have to dial an area code. Okay, all right, that's it.